cases. So we only really need the first quadrant. And x equals 0. Which line is x equals 0? The y-axis. So x equals 0, that's our y-axis here. And y equals 8. What type of line is that going to be? Horizontal line at 8. So we'll have y equals 8 here. And then y equals x squared. I'm going to go ahead and graph it with it solved for y right now because it's easier to graph that way. So 0 squared is 0. 1 squared is 1, but then we'll have to multiply it by 2 to give us 2. 2 squared is 4, but we have to multiply that by 2, which will give us 8. So here. And so in this case, we are looking, the area we're looking at is this area here. And if we were just having to find that area, we could do it in terms of x or y, and it would work out pretty easily, because if we're doing x, we could just do top, which is the red line, minus the bottom, which is the green line. Or if we were doing in terms of y, we could do the right, which is the green line, minus the left, which is the blue line. And so if we were just finding an area, either one would work well here. But whenever we're rotating around the x-axis and the y-axis, you have to do everything in terms of y. Because what you're doing is you're taking a sliver right here and you're rotating it around that y-axis. So, so whenever you do that, this distance from 0 over to the y, that has to be in terms of y. If you do it in terms of x, it's not giving you that horizontal distance, it's giving you like a vertical distance there, which would be like the area under the curve here. So, so if you're rotating around a vertical line, you have to integrate with respect to y. If you're rotating around a horizontal line, you have to integrate with respect to x. So for this, we're going to do pi times the integral of, and we're going to run into some trouble here because this has to be in terms of y. So y equals 2x squared is not currently in terms of y. So we have to do, we're going to take y equals 2x squared. We're going to divide by 2. So y over 2 equals x squared. And we're going to square root both sides. So x equals, technically there'd be a plus or minus there, but we'll see when we plug it in. It really doesn't matter whether you use the plus or minus. Since we're using the right-hand side, I'd use the plus, but it's not going to matter when you plug it in anyway, because when we plug it in, we do pi times the integral of square root of y over 2 squared. So since you square it, it's not going to matter whether you have the positive or the negative there. And I'll put a dy. And just like with our area, whenever we're integrating with respect to y, our limits have to come from the y. So what should my limits be here? 0 to 8. Okay, so they have to come from the y-axis. Your lowest y coordinate is 0, your highest y coordinate is 8.
So it would be like 0.
Right, 0 to 2 would be if we were rotating it around the x-axis. There. So, we are going to first go ahead and square the square root. So we really just have pi times the integral from 0 to 8 of y over 2 dy. And when we integrate this y over 2 is really like 1/2 y. And actually, I'm going to do this. I'm going to do pi over 2, integral from 0 to 8 of y dy. If we do that, then we don't even have to worry about that fraction. And so when we integrate y, we'll have y squared and 1/2 here. We'll have that pi over 2. And we'll evaluate this from 0 to 8. So we've got pi over 4. And then we'll have 8 squared minus 0 squared. So pi over 4 times 64. And we'll see 64 divided by 4 is going to be 16. So we get 16 pi as our answer. So that would be our volume. Real fast. Okay, questions? Okay, let's do one more here. And this one actually is not with respect to y, but it's a little bit different. There's something different about it we have to know. Alright, so be really careful because still, even, I always tell my kids in all of my classes, even in calculus, everybody still messes this up. Y equals 1, what kind of line is it? It is a horizontal line. You want to think that it's vertical because it says y equals, but it's a horizontal line. So we're rotating around a horizontal line here. So let's graph it first. And we're going to have 2 minus x squared. So 2 minus x squared would, actually let me go a little bit longer here. So that is upside down. It has a y-intercept at 2. Yes. G of x equals 1 here. That is this line here. And this is y equals 1. This is the line that we're rotating around. So we are looking at this area. And we're going to rotate around this line. So this problem is going to be a little bit different because we are not rotating around the x-axis. We're rotating around y equals 1. So we're going to have to adjust what we've been doing just a little bit so that it will rotate around the line y equals 1 instead of the x-axis. So like right now, if I plug numbers into 2 minus x squared, it's giving me the distance that this graph is from the x-axis, right? If I plug in 0, I get 2, right? If I plug in 1, I get 1. So it's giving me the distance that point is vertically from the x-axis. But I don't want to rotate around the x-axis. I want to rotate around the line y equals 1. So if we think of, like, this length here, that is our radius, right? And so to find that length, our radius would be 2 minus x squared. And then, so we take our top equation, and then we would have to subtract the bottom equation, which would be 1. Right, so that radius there is going to be 1 minus x squared. Okay, so what we have to do differently here, on everything else, we were just thinking of our radius as the equation. Because on everything else, our radius was just the equation, because we were rotating around the x-axis or the y-axis, which meant the equation for those lines was 0. We could have done this, but we would have just had 2 minus x squared minus 0. So it wouldn't have changed anything about the problem. But in this case, because we have a radius here that's been shortened by moving that line that we're rotating around up, we have to subtract that 1 there. So since our radius is 1 minus x squared, we're going to do pi times the integral of 1 minus x squared dx. And this is a horizontal line, so we're going to use our limits from our x. What should we use? -1 to 1. And I'm trying to think, there's some of these that it doesn't work if you split it in half. I think this one will still work if you split it in half. But there's some of them that don't. So we'll just do this one this way. So we have pi integral from -1 to 1 of, this would be 1 minus 2x squared plus x to the 4th. If we multiply that out, the square double square. Okay, and then we're going to integrate, so the pi will stay out here. We'll have x minus 2/3 x to the 3rd plus 1/5 x to the 5th. And we'll evaluate that from -1 to 1. So we will have 1 minus 2/3 plus 1/5 whenever we plug in 1. And then we'll have -1 plus 2/3 minus 1/5 whenever we plug in the -1. And so that makes this plus and a minus and a plus whenever we do that. So pi will have 2 minus 4/3 plus 2/5 put everything over 15, so that'll be 30 over 15 minus, multiply by 5 here, so minus 20 over 15 plus 6 over 15. So we get 16 pi over 15. And that last part, it's okay with me if you resort to your calculator. Be able to do it by hand, because something like this is sort of like the upper limits of what I think you might actually see on the AP exam as far as having to do it on the non-calculator section. Typically, they don't give you anything much worse than that. Our book, however, does give you problems that are worse than that, so it's okay if you go to your calculator on that. So this area is 16 pi over 15. Essentially what you've done is you've moved the x-axis up 1, Because really, you're just taking like 1 minus x squared, which would be the graph of this if this was the x-axis, and rotating it around that line. Okay, same thing could be done with this whenever you're dealing with respect to y as well. Okay, questions? Okay, so your assignment, which you got about 20 minutes to go ahead and get started on, is going to be page, page 425. And we're going to do 7 through 10. And let's see. $21 and I think just 21. I'm afraid 20. I want to give you 24, but I'm afraid it's a little more complicated than what I need to be. Hold on. Wait, that's x equals the first line. I want one with the x, but it... Oh, wait. Never mind. Here's the other one I was going to give you. 18 and 21. Okay, so go ahead and get started on those now.
We'll do